Hello, this is Zhen Huang from Transphorm, and you are at APEC 2014 in front of our booth. Welcome to the booth, and I'd like to introduce you to our newest demos and show you how our 600-volt gallium nitride devices would perform in applications. The first demo I want to show you is the totem pole PFC. With 230-volt input and 390-volt output, the PFC right now is running at 99.2% efficiency, which is the highest you can get because we eliminate all the diode job, as this is the simplest bridgeless PFC. So we're looking at a universal 50 kHz, 1 kilowatt totem pole PFC, and running at 50% load. This board doesn't need any active cooling, and at full load it just takes very little cooling because the efficiency at full load will still reach 98.5 efficiency. The two GaN devices sitting here is our fast switching, and there's the two slow silicon MOSFETs just to do the rectifying. The whole board is controlled by digital control card, and as we can see, the board is very clean with minimum components. Comparing to other bridgeless PFC topology, the totem pole PFC has the least component count. So even gallium nitride devices right now is considered to have a higher price comparing to silicon devices. The total BOM cost can actually be lower than a traditional bridgeless PFC. And this is enabled by gallium nitride HAM's ultra-low reverse recovery and innovative totem pole topology.
Well, hi, this is Jim Honey with Transphorm. We're at APEC 2014 at the Transphorm booth. And what we're demonstrating here is a single-phase inverter, up to 240 volts AC out. This could be, for example, a small solar inverter, a UPS. We're doing this with 4 of our 600-volt GaN transistors in a full bridge, switching at 100 kilohertz. Efficiency peaks around 98.7%. If you look here at the circuit, there's 4 TO220s, 2 half bridges, back-to-back on heat sinks, filtered output, relatively simple modulation scheme to get the 60 hertz sinusoidal output. This particular board that we brought to the show, we actually ran for 1,000 hours with a case temperature of 100 degrees C just to get a feel for the stability of the circuit. And since it was running so well, we just brought it to the show. Here's a block diagram of the circuit, and again, it's just a simple full bridge with a filtered output. And we run this at 1 kilowatt with no forced air, 1.5, 1.6 kilowatts with forced air. Really just a question of heat transfer at that point. Could be a 2 kilowatt design if you wanted it to be. Typical rise times on this scope, we're showing 5.5 nanosecond rise on a 340 volt bus. Just efficient, simple, high frequency switching with GaN transistors. So here's another example of a GaN inverter that we've shown previous years, a 3-phase motor drive. Again, same idea, 3 simple half bridges, 2 transistors each. By switching at high frequencies, hundreds of kilohertz, output filters become small and small enough to be integrated into the inverter. So that's it. High frequency, efficient switching in inverters with gallium nitride. Thank you very much.
The next demo I want to introduce is all-in-one power supply with 115-volt input, 12-volt output, and 9 amp output. At about 40% load, 45% load, the demo right now reaches 94.2% efficiency, which is higher than the platinum standard. The board has 2 parts, including a 200 kHz PFC and a 200 kHz LLC. Notice that it's not just a small design, but it also meeting most of the industry standards. For example, we have the EMI filter that actually passed EMI test. The hold-up time is enough with the electrolytic capacitors, and we meet the ripple requirement with the output capacitors. So basically, we are showing a very ready design, all-in-one design that can compare to current state-of-the-art designs and showing the gallium nitride benefit. And here is an example of the LLC portion of this board and showing how small it can be. The next step we are going to do is to further increase the frequency to to 500 kHz and shrink the inductor even more. Transphorm is happy to introduce you our 600 volt, fully qualified, JEDEC qualified gallium nitride on silicon devices. With the 3 demos we just showed you, you can see that gallium nitride devices are ready for modern power supply designs that demands performance, size, and simplicity.